Greetings everybody. What you see here is a problem I found on our assignment on my math lab, and I'd like to show you how to do it. But before I start solving this integral directly, there's some things that are going to come up that I think we should talk about by themselves. Okay, so here they are. It deals with identities involving square roots of squares and absolute value. So first thing is this. What do you think the square root of a number squared is? It would be easy to think that the square root cancels the square and that the square root of a number squared is the number. But notice I put in this identity that the square root of a number squared is the absolute value of the number. Why did I do that? Well, so if I left the opposite value off of this, it would work fine for positive numbers. Imagine if you let n, that number, be 9. It would say square root of 81 is 9 if I left off the absolute value. And that's true. Okay, so you might say, well, is the absolute value is necessary at all? It is in case that number n were negative. So look, what if n was negative 4? So say I put negative 4 into this. It would say the square root of negative 4 squared is equal to the absolute value of negative 4. Is that true? So negative 4 squared is positive 16. And the absolute value of negative 4 is 4. So it is true. Okay, but if I had left off that absolute value, if I had thought that the square root of n squared is just n, it wouldn't apply, it wouldn't work, it would fail if the number was negative. Okay, all right, so there's an identity for how to simplify the square root of n squared, n being whatever undetermined number. Now I mentioned that because through working this one, the original problem, we're going to have to simplify the square root of tangent squared. Okay, and if we were to say that that was just tangent, it would get us into trouble. All right, so all right, that's the first thing. Now second thing about absolute value. Notice how the square root of n squared reduces to an absolute value. How does absolute value further reduce? Okay, so let's talk about like this here, my second identity. I'll say the square root of some number n is that number n if you know that that number is greater than or equal to 0. That just says the absolute value of a positive number is that number. The other form we need to talk about is that the absolute value of a number n is the opposite of n, is the opposite of the number if that number was less than or equal to 0. Okay, and I shouldn't include the or equals to in both of these cases, but in the case of 0, it's going to work either way. All right, now as an example, so what if n was 9? Would this statement work? Would it do what I need it to do? So if n was 9, it would say the absolute value of 9 is, well, is 9 greater than 0? Yes, so it's 9. All right. And what if n was negative 4? Okay, so the absolute value of negative 4 is negative 4 greater than or less than 0? It's less than, so the absolute value of negative 4 is the opposite of negative 4, which is 4, which works out to be correct. Okay, now you might say, well, why are you complicating absolute value? We know how to evaluate the absolute value of negative 4 or 9. Do we need this formula? And I'd say, well, we need it in case this number n could take a range of different values, or if we didn't know what it was. Okay, this is how I can reduce it by not knowing exactly what it's going to be. Okay, if I know that n was positive, I would just say it's n. And if it was negative, I would say negative n. Okay, all right, now we will run into both of these as we go about reducing this. Now, quick disclaimer. If you saw this on my math lab, you could use the help features and it will show you something. It will be a little bit different than what I show you. But even then, I think it leaves some details out. So I'm going to try to include as much detail as possible in a short video. So here we go. So I aim to solve this integral. As it is, I don't really have any way to work it. Okay, this expression root secant squared theta minus 1 is a little bit too complicated for me to do anything with. You might say, well, at this point, what techniques have we learned for integrals? You can solve integrals directly by some known formula. So for example, If I go to, here's something I've posted on our Canvas page. Here's a variety of formulas I would suggest that you use or that you might need to refer to for the first test. And the whole page isn't loading, but on it you'll see that there are some basic integration formulas. Okay, so who knows, maybe you would find this one on there. Okay, I don't think so. So there's not a formula that will directly evaluate it for us. It's also not any other technique like U substitution or integration by parts, so on. So I'm just going to have to turn it into something else. You know, when you took pre-calculus, you learned trig identities, and you learned how to take one thing and convert it to something else. And the reason why you learn to do that, one reason at least, is so that if I have an integral and I can't really work with it the way that it is, and it involves a trig function, maybe I can turn it into something else. Okay, so there is a trig identity that says secant squared theta minus 1 is tangent squared. And that would be a step in the right direction. That would at least simplify it. Okay, it might not get me all the way where I want to be, but it's definitely simpler than what I started with. Okay, now as I've worked through this, I've put like footnotes here, and I've given you my reasons. So my reasoning for going from here to here under footnote 1 is, yeah, there's a trig identity. Most of the time we would see it written as tangent squared theta plus 1 is secant squared. But you could turn that around and say tangent squared is secant squared theta minus 1. And that's what I've used, and I've reduced it like this. Now, how are we going to get from the square root of tangent squared theta to something even simpler? Well, we did talk about over here how you can reduce the square root of a number squared. Okay, so the square root of n squared is absolute value of n. By extension, the square root of tangent squared is absolute value of tangent. Okay, now so that is just this. Okay, so under footnote 2, getting from here down to there, this is involved. What else is involved is this. Now, let's pause for a second. Ultimately, my goal is to solve this integral. And to do that, I'll need to find the antiderivative of whatever function is in there. And with absolute value of tangent theta, that's still not something that I think I can work with. Okay? If I tried to look up some formula for what is the antiderivative or indefinite integral of absolute value of tangent theta, I might have trouble finding it. Okay? All right. So here's what we can do. Absolute value does break down like this according to whether that number in there was positive or negative. So about that tangent theta, is there some like pattern, some regularity to when tangent of an angle is positive or negative? Say definitely. There's definitely some predictability to that. Tangent is positive, I could say, in quadrants 1 or 3. It's negative in quadrants 2 or 4. With regards to the bounds of this integral, I could say, well, tangent's positive if the angle is from 0 to pi over 3. That would put me in quadrant 1. And it would be negative if the angle is from negative pi over 3 to 0. That put me in quadrant 4. So then that gives me some way to predict it. Okay? So what I'll do is this. So that I can evaluate that absolute value, get rid of it, in other words. I'll take my bounds of integration, I'll split them up, I'll integrate over quadrant 4, negative pi over 3 to 0. I'll pick back up at the 0 and go to pi over 3. That takes me all the way from the lower bound to the upper bound, stopping at 0 to divide it between where tangent is negative and positive. Okay, so what is the absolute value of something when we know it's negative? It's the opposite of what it is. So the absolute value of n is the opposite of n if you know n's negative. So I'll say this. I'll say the absolute value of tangent theta is negative tangent theta if I know that tangent's negative, and it would be from negative pi over 3 to 0. And then over here, what's the absolute value of a number that you know is positive? It is just that number. The absolute value of n is n if you know that n is positive. So in this case, from 0 to pi over 3 in quadrant 1, I know tangent's positive. So the absolute value of tangent under that condition is tangent. Okay? All right, so that is the reasoning for getting us from here to here. Okay? That's why I started the video off by running through those identities. Okay, now from this point, here's what we'll do. There is a formula for basic integration for tangent theta. Okay, and here it is. You can find it on this formula sheet. So if, again, you go to modules, this is on our Canvas page, under the test 1 module, suggested formulas for test 1, you will find this formula that I'm about to use here for the indefinite integral of tangent theta. Okay, it is this. The indefinite integral, the antiderivative of tangent theta is negative natural log absolute cosine theta plus c. You may also see it as natural log positive absolute value of secant theta plus c. Either one of those will work. Okay, I happen to use the cosine, but that's what we want. Okay, so what is this? What is the antiderivative of tangent theta? I got it right over here, and I'm going to use that. Okay, so I'll find that on my list of formulas that I'll use as I go through my assignment. All right, so see, I started with something that I really couldn't work with to integrate, and I gradually broke it down more and more until finally it was to the point where I had either knowledge of how to do it or I had some formula to apply to it at that point. Okay, all right, so there's my antiderivative. What you see here is evaluating by the fundamental theorem of calculus. Okay, you're going to get a 1/2 in there for the angle negative pi over 3 or pi over 3, but that you're going to get a positive number, so you can lose the absolute value at that point. And we'll get all this, and we'll get down here after doing some calculations, negative 18 natural log 1 over 2. Okay, now that seems like it's some final answer. It still doesn't match this one though. Okay, and the deal there is that, you know, just like trig functions have lots of identities that can be used, logarithms do too. So let's see, let's say I'm here, negative 18 natural log 1/2, and I'm trying to figure out, well, how does that final answer positive 18 natural log 2? Well, there is a rule, one of many rules that apply to logarithms. It says logarithm of any base of one number divided by another is log base b of m minus subtraction on the outside log base b of n. So you could say what happened, the ultimate simplification, was we say, well, we got a negative 18, and natural log of 1 divided by 2 is natural log of 1 minus natural log of 2. Natural log of 1, everywhere you see it, is 0. So I get negative 18, distribute, negative natural log of 2, positive 18 natural log of 2. Okay, so that's how we solve it. There's a fair amount going on, but I think if you start off by understanding at least what we can do with the square root of a square and the absolute value, break it down in this context, that's a lot of it, all right? It's not everything, but it's a lot of it. Another thing, I mentioned earlier that if you were solving this on my math lab and you use the help feature there, it would show you something a little bit different. What I think you would see there is that we could break this integral down into just going from 0 to pi over 3, okay, and doubling it. It turns out that this function is even, okay, and that's another story that I didn't want to go into right now. And the reason is if these bounds were different, that might not be the case, all right? So I don't want to rely on doing it that way, because I think if I stick to what I see in my math lab, all of a sudden it would break down if this was a little bit different. So what I've showed you here would work even if the bounds were different. You could just evaluate quadrants 1, 2, 3, 4, absolute value, where's the function, positive or negative, and break down from there. Okay, so that's my example that I want to show you for today. Is with everything, especially in calculus too, there are so many places that you could go for further study. Maybe you're okay with most of this. It's just this that's really hanging you up. Well, we need to talk about that. Maybe you're okay with most of it, but it's these, or maybe it's several things. So those are conversations that we need to have that I can't fit into one video. All right. So you watch the video, anything there that's not clear, we can have a separate conversation, or I can make a separate video about. And I think if you stick with it, you can understand all of it that you want.